Hi, my name is Karen Kortz. I teach at the Community College of Rhode Island, and I'm here to tell you about my experience with changing some assignments to make them more quantitatively literate. So I went to different members of my department and I approached them and asked them if they're willing and able to change some of their assignments so that they better fit the rubric on quantitative literacy. And I had mixed experiences where some of the faculty members were very open to the changes and some of them were not quite as open. So I'm going to be telling you today about one of the experiences I had with some members of my department who had created labs together and they were very willing to change them. So if you look at some of the documents that are attached to this file, you will see that there's the original lab that they have not before any changes were made. The basic idea is that students would take a couple different balls and drop them in sand and see how big of a crater those balls would make in the sand. They would calculate the kinetic energy of those balls and compare that to the crater size that was made in the sand. The initial experiment was really interesting and it was fun for students to do, but when we looked at it we realized that there was a lot more that we can work on to increase the different levels of what we're expecting from the students and to have it better conform with the rubric. So after I met with the faculty members, we talked about some of the different ideas of how we can change it. We actually took out the rubric and we looked at it and looked at some of the different lines in the rubric and tried to figure out how we could add some of those different factors into this assignment. So the first thing that we did was that we decided to add a prediction. So before the students actually did anything, we had them predict which ball would make the bigger crater in the sand. And this gets the students invested in the assignment. It gets them so that they themselves are kind of curious about what the end result is going to be. Then what we did was they filled out the same table afterwards where they had to fill out the mass, the drop time, the impact velocity, and they calculated the kinetic energy, just as they did before. But after they did that, we asked them questions then to build on that initial knowledge. So we asked them then which ball had the most kinetic energy, and we then had them compare that to their prediction. Was their prediction correct? And we had them then figure out which ball made the biggest crater. And again, we had them compare then the energy, the kinetic energy, to the size of the crater. So now they're making a comparison between the data that they collected and their observations and their measurements. We then had them take that information and apply it to figure out which representation best shows the relationship between the kinetic energy and the crater size. In addition, we then had them take this knowledge that they have and apply that to a new situation. And the new situation required them to think about being the producer of a movie and you want to destroy a city with a crater, an impact crater. And we had them then figure out which size impact crater would be the best one to destroy this city, taking that knowledge that they have about kinetic energy and crater size and applying it to a new situation.